This video is the AV production for meteorology group MTA16333. The themes for this semester were visual computing and human perception. With the project, we had to create a program that utilizes the method of how a computer sees. We decided to work with face detection, as in today's increasingly digital world, face detection plays a number of roles such as information and data security and human-computer interaction. It seemed best to focus on the human-computer interaction aspect of it, as it matches and relates to our field of study the best. Our group has chosen to create something similar to Snapchat, where the program would take a picture of the users, find their facial features, the eyes and the mouth in this case, and superimpose a 3D mustache onto their faces after doing the necessary calculations. This led us to the formulation of our initial problem statement. How can we build a system to detect facial features and accurately apply cosmetic changes to it?
The first step of the program is image acquisition. Before the image acquisition takes place, we have to ensure that it can be done under ideal conditions. These conditions include proper lighting so that the face is lit evenly, making sure that the facial features are clearly distinguishable, and eliminating the chance of false positive by getting rid of the shadows. Next up is correcting the background. This is to make it easier for the program to find the face. We can either use a single colored background, or if that's not possible, blurring the background of the image will also improve the program's accuracy. Since we are using the basic webcam of a laptop, using a simple background will be our way of correcting this factor. After it is certain that any interferences are accounted for or are minimized, the first hurdle to overcome is finding the face candidates on an image. While doing our research, we found that there are 4 possible ways of achieving this: knowledge-based methods, feature-invariant methods, template matching, and appearance-based methods. We found that for our purposes, knowledge-based methods and template matching work the best, because the other 2 rely on machine learning.
We ended up using skin color segmentation since we were to take bust photographs of our subjects, so our goal was to isolate skin regions from non-skin regions. Our research suggests that most powerful feature in face detection is skin color. The ideal color space is the YCBCR color space, as it corresponds most to human visual perception. Y stands for brightness, CR is the red component, and CB is the blue component. The power of skin color segmentation lies in its property of being effective after rotation, scaling, and partial occlusion. After the face candidates have been found, edge detection is used to find face contours to narrow a field of interest. The Kenny method was found to be the most effective one. The Kenny method results in 1 pixel wide edges, which are grouped together. After having detected a face candidate, the program determines whether it is truly a face or not by localizing facial features. To accomplish this, we are using blob extraction, which finds the boundaries and isolates an object on an image by looking at interconnected pixels. The program uses a graph-file recursive algorithm. We use the width-height ratio of a blob to determine whether it is an eye or the mouth based on hard-coded values. After these features have been successfully identified, the program will use their locations and place a mustache directly above the mouth or a monocle on one of the eyes. How can we use skin color segmentation, edge detection, and blob extraction to detect a face and accurately place a mustache on it? The program must achieve an average true positive rate of 0.5 or more, achieve an average pixel offset value less than 7 pixels in the x direction measured from the center of the blob, and achieve an average pixel offset value less than 9 pixels in the y direction measured from the center of the blob.
The 3D assets were created in ZBrush and afterwards imported into Unity. We've not put too much focus on creating the UI for this project, as we put emphasis on making the algorithm work rather than on the user needs. The 3 components are the refresh button, the shutter release, and buttons for choosing the different mustaches. After choosing the methods we ended up using, the program was put together. Image acquisition is done by making Unity utilize the webcam in the laptop.
For the orientation around the Z-axis, we take the position of the eyes and calculate the angle of the line between them relative to the horizon. For placing the mustaches on the correct position, we take the point between the 2 eyes and find the vector pointing from the mouth to that position. After that, we put the mustache a fourth of that vector above the mouth, as it is relatively close for all our mustache models. Then we fine-tune the placement by a few pixels for them separately. For placing the monocle, we take the position of one of the eyes.
The testing will mainly focus on the technical aspect of the program. 3 parameters will be used to test the algorithm: detection, algorithm performance under different circumstances, and the accuracy of mustache placement. Testing has been done with the inclusion of 18 fellow students as test subjects. Pictures were taken in 3 different angles. Each subject had a maximum of 5 tries to take a successful picture of themselves. the program had a 50% success rate. In order to understand these results, the gathered information was put in a confusion matrix. We have found that not counting the head tilting, the variables causing the most interference were beards and glasses. During the process of creating and testing the program, it became apparent that light is one of the most important factors. After testing, we found that while our program detects faces with an above 0.5 true positive rate, while the test with uneven light and/or participant with beards or glasses had a true positive rate lower than that. It did so with slight errors in positioning the blobs, with the average pixel-wise offset ranging from 3.2 to 7.5. The program can be considered a solution to the problem formulation.